Welcome back to the next episode of Configuring NMS Prime. So last time we stopped after we were able to successfully provision DOCSIS devices and also have them set up to do all the monitoring, both the real-time monitoring and also the monitoring over time using our diagrams. Today we are going to look at provisioning FTTH or DSL or GPON devices with our generic approach. To do this, we need two things to enable. First off, we need PPPoE and radius, and secondly, we also need ACS or CWMP to provision the devices. So our generic approach is that we don't really care about the technology which is underlying, which is connecting our DSL, GPON or active Ethernet devices. What we in the end care is that we have a layer 2 link between the end device at the customer and our net gateway. Could be a DSLAM, could be a GPON like an OLT or a normal switch. And on top of this layer 2 link, we provide a PPPoE session. And using this PPPoE session, we are able to limit the speed of the customers in both directions. So to do this, we have a built-in radius server. So we are using 3 radius for this functionality. And of course, we need a router which is terminating PPPoE sessions. So we have to configure now the router or the BRAS or BNG to talk with our NMS Prime radius server. So once the device is connecting to the BNG will forward the credentials of the device to our NMS Prime server via radius. We will look into a database to see if we know this device, and if we do, we are sending attributes back to the router such that the router will know what kind of speed in the upstream and downstream direction will need to be shaped. And besides this, we also of course want to later on provision the device. In the DOCSIS case, it's fairly simple because we have config files. In the FTTH or GPON DSL case, it's a little bit more complicated and it's a little bit more, specific depending on the technology you use. For example, if we talk about OLTs, you may use OCMI to do this sort of stuff. And since we don't really want to rely on the specifics of the various different vendors, we are concentrating on ACS, so TR-069 provisioning basically. And for this, we also have a built-in Genie ACS server, which we provision from NMS Prime. So basically, whenever you create a modem, you will always have to specify the config file, and based on the config file type, we know, is it a DOCSIS modem, or are we talking about a TR-069 modem, basically, a CPE. And if you choose the TR-069 config file, then we internally don't create DOCSIS config files, but we talk with Genie ACS via its API to push in the presets and the provisions. And the same, the templating engine we talked before, that we can replace variables and stuff like this, is of course also possible in the TR-069 side of things. So the question may now be, how does the CPE know where our ACS server is located, which URL it has? There are 3 different possibilities how to do this. First off, of course, you can do this in a manual case. So you just connect to the graphical user interface of the CPE and set the credentials there. Of course, this is tedious, especially if you have different or many devices, and if you factory reset the device, it will lose its manual configuration, and then you can't reprovision the device. The second possibility is to have a pre-configured profile which you push onto the CPE. So, for example, in the German market, there is AVM boxes, Fritz boxes from AVM, and they have what's called a reset, a configuration which is surviving factory resets. And in there, you can push the ACS location. For example, you could push a default PPPoE credentials, and which will always go online, but maybe with a limited speed, and also the ACS URL. And then once the device is coming up, it will talk to the BNG, we'll get a PPPoE session with default settings, then it will connect to our ACS server via the URL, we will identify the device based on its serial number, and then we will push the PPP or the device-specific PPPoE credentials and other settings onto the device, and then it is provisioned. And last but not least, we can also do bootstrapping via DHCP, which is the first point here. So basically what that means is if the device is configured in such a way that it always, after factory reset, will do DHCP, we can give it an IP address from a certain DHCP pool, and with a certain option, you can also tell the device that it should be using or what kind of ACS URL it should be using. So basically there, it will start with DHCP, get the information from the ACS, or get the information where the ACS is located, then we'll connect to it using normal IP. We'll get a new PPPoE interface via TR-069 and also the proper credentials, and then it will default to the PPPoE connection, and we will use it later on for getting to the internet. And of course, if we hand out IP via DHCP, this will be in a pool which is not routed to the internet, so this will only be used for initially talking with the device, and possibly later on also for managing the device. So these are the three possibilities how to push the ACS information into the device. Today we will have a look at the second case here with a Fritzbox from AVM, where we already have a preset installed on the device. So when the device is coming up, it will start with a default PPPoE profile, and we'll know where the ACS URL is connected right away. And just as additional information, since we will mostly look into this today, when you want to do the bootstrapping via DHCP, basically what you have to do is just go into the DHCP location folder and just add a new config file. You can of course use the existing examples, for example here, which we created last time with the shared network and the subnet and so on. Based on this, we create a new file. We may call it acs.conf, and what we put in here is something like this. So it's basically a new shared network. Now in this case, this is not done via a relay agent, but the CPEs are directly connected to the VM, or via, or at least in the right broadcast domain, or in the same broadcast domain. And here we just create a new IP pool. Here you have the range, and the important bit, obviously you need the router, subnet mask and so on, the usual information, but the important bit here is the vendor option space ACS, and here we have an option ACS URL, which will then be encoded into a DHCP option and then pushed to the device, and hopefully the device will evaluate this option and will then know how to access our ACS server. So you would add this one, and then of course you would also need to add or load this file during start of the DHCP server. So where we usually include, you can just include another file, and just call it acs.conf. Now if you restart DHCP server, DHCPD, now it's loaded, and from now on devices directly connected to your VM will get an IP address from the rule we set up here, and you will also get this information. And this way, hopefully, if they evaluate this option, we'll be able to talk to our Genie ACS. The next task will be setting up the BNG and also the interconnection between the PNG and NMS Prime, or better yet, the radius servers, or free radius, which is built into NMS Prime. So therefore, first we can go to the router, which is terminating the PPPoE session, so basically the BNG. And here we're using an EdgeMax from Ubiquiti, but really you can use whatever router you wish, as long as it can act as a BNG and can terminate PPPoE sessions. So therefore here we have our tab PPPoE. This was already set up before. Of course, what I need to change now is the server IP, because we are on 172.20.0.3. This is my secret. I could call it as whatever I wish. In this case, it just happens to be like this. And you can also, of course, need to specify on what kind of interfaces you want to listen for PPPoE sessions and terminate PPPoE sessions. DNS is important as well, and here's the IP range which the clients will get once they are successfully authenticated and authorized. In this case, we have a carrier-grade NAT pool, and in this case now we can either say, okay, the HMX should perform assigning IP address to clients, or we can also do this later on via free radius with an extension. So what we need to do now is, of course, we save it first, because I changed this one right now. And what I will do now is I go to NMS Prime and will set up a new net gateway down below here. If you remember, before we already set up the CMTS. Now I'm going to add a BNG. I call it dev RT01. So this is ubiquity. A router in this case. Of course, this is a BNG PRS. I call it dev RT01. And the IP of it is, of course, this one. And now I'll have to say what the secret will be. And the secret is this one. I could set the ports here. We will later do this. This will be needed to restart devices or basically kill PPPoE sessions on demand from NMS Prime. So we save it. And now, of course, what we also need to do is open up the firewall such that the router will be able to talk with us using the radius protocol. For this, we need to look at the firewall conf again. So we are going to use our firewall command, list all zones, and here's just a filter to show only the active zones. And you see we have an NMS Prime zone which is able to talk radius. And as you can see, as it already happens, we are in the right sources range, so we don't have to do anything at all in this case. What happened in the background now as well is, of course, if we go to our database, you will see if I go to NMS Prime, there should be now in NMS Prime dot netgateway. You will see now that, of course, there is the router and our CMTS. And of course, at the same time, it should also happen that in the radius database, we will also have NAS now set up. So let's have a look. Yeah, you can see the router is known to us now with the secret. So now radius will be able to evaluate packets coming from this device and will not ignore them anymore. The next step we want to do is setting up IP pools in NMS Prime for this router. So if we look into our database for radius, we have a table called RAD IP pool, and currently this is completely empty. What we can do now is basically just like we had here, we can set up a pool from 164.32.1 to 253, and this way not the router will manage the IP address, but we will do it via radius. So we can go to IP pools just like we did for the CMTSs before, and we set one for the private CPEs because they are carrier grade NATed. Now we say this should be 32/24, and it should start here 32.1 and should stop at 32.253. The router IP will be 254, and the broadcast, I mean, it's not really needed, the broadcast as such, because this is PPPoE. It's a point-to-point interface, but anyway, we'll set it up like this. DNS servers are actually specified here, but we can leave it like this. And now what you will see is, once we save this, that in our HUD IP pool we now have all the IP addresses set up from 1 to 253. And now if a device is coming up or is coming, and is probably successfully authenticated, then we will choose one IP address from the pool and we'll assign it, and then you will see that the calling station ID, for example, the identifier of this one, will be set up here properly, and also the username. And this way we know what kind of IP addresses are already in use and which not. This way we can also know how much our IP pool is already exhausted, and we can give a warning and show it on the dashboard once the IP pool is getting somewhat full. Another feature here is that you could set up static IP address assignments to devices, and this way we always know from NMS Prime directly what kind of IP addresses are used in which way, which you wouldn't have this information, of course, if you would rely on the router doing all the IP address assignment. Since we changed the Radius server IP address now to our new VM, we should some Radius requests coming in via the interface. So to do this, we can use TCP dump. I'm now listening on this interface here, and I'm listening on both 1812 and 1813. One is for the request and other is for the accounting. So if we run TCP dump now, we will see eventually that some packets are coming in. You see I got one here, and if we open this one up, you will see that there are some access requests coming in. So in this case, it's on port 1812. I can make it a little bit bigger for you. And you see we're not currently answering because we don't know this device. The device in question is in this case, F510. Then we have another one. And eventually we should also see a Fritzbox. Let's have a look. Not yet, but soon it will come. So what we can already start doing is setting up a new config file for TR-069 provisioning. The TR-069 provisions will only be running in the bootstrap case, so directly after the device is coming from a factory reset. So we're going to go to config files here. You already know the base config file we touched before in the Doxys case. Now we're going to create a TR-069 provision, and we call it AVM FB5491 for the Fritzbox 5491. We don't have a parent, and for the commands we have this. We will later come on what these commands are here, but the important bit is starting from here basically. So you can see, and this is kind of our own syntax because we deemed that the Genie ACS syntax is a little bit complicated for the end user. So here we set the periodic inform enable to true. We say that the device should come up with a periodic inform every 5 minutes. Here we say what the PPPoE credentials should be, and these are the modem specific ones. So as I said before, we per default it comes up with default credentials, and later on there will be device specific ones. And also for the telephony provision, you can see down below here, we also can enable and provision the first voice line of the Fritzbox. So we can say, okay, this should be maybe a PPPoE device. So this should be our analysis dashboard. Now we can hit save, and now we have created the first TR-069 config file. So let's look back at Radius to see if we can see the Fritzbox coming up as well. Microtik. Here we have one with the name Fritzbox 5491, and obviously we do not answer to it because we don't know this device. So the Radius server is not aware that such a device exists, so we should create one now. For this, we go back to our contract, which we used before. So here we have the NMS Prime contract, and we already have our 2 Doxys modems, and now we'll create another one, namely the Fritzbox device. So we choose the config file which is created, and now we have to supply a MAC address. So let's do this. This is the MAC address of the device. It's not strictly necessary for PPPoE, but we can put it in anyway. Then we have our serial number. This is important if you want to provision via TR-069. And also the username obviously will be this one. And I already provisioned this before, so I know that the password should be this. I want the device to have internet access. I don't have set up a public IP address pool yet, so I don't want public IPs. I want to NAT them. The QoS is fine. This is 10 megbits in the downstream, 1 megbit in the upstream, and the rest I can leave as is. It's just taken over the usual information from the contract, and it will be automatically geocoded. And now we can go save and restart. Okay, it's telling me I have an invalid input. Alright, the issue was that I had enabled the Altiplano module, which requires a fiber name to specify. I did not, or I do not use Altiplano at this point in time and in this instance, so I disabled the module now. And so if we use the same information and hit save now, we should see that the modem is created. Here we go. And we should also see that we provisioned everything on the radius side. So if we go to our VM again and look at the radius server, so here we have all our tables. We should see that we have one entry in our, for example, the RAD check. There you see, we say there should be a username, a device with a username FB5491 with this clear text password, and it should receive an IP address from the pool CPPriv. If you remember, we had the red IP pool, and here you can see all the IPs which belong to this pool name. Besides this, we should see in our we don't have a group check, but we should have group replies. So let's look here. Here you can see multiple entries. The first one is the group 0, which will always be chosen. This is just our default configuration. So we have we only allow one device per username. So the port limit is 1. We have a framed MTU, maximum transfer unit of 1492, which works well with Ethernet. We want to use PPPoE. It should be a framed user, and we want updates every 5 minutes. The session timeout should be 1 day, so after 1 day we always disconnect, or the router will disconnect the session, and a new session needs to be started up. And with a fall through, so basically from here we go to the next group. And so let's have a look what kind of groups the device has, and therefore we need to use the RAD user group table. RAD user group. And here you can see Fritzbox is in both group 0, so basically our default, and it's also in group 4, which is this, and this is our 10 meg upstream and 1 megbit downstream. 10 megbit downstream and 1 megbit upstream. And we have multiple properties, one for Microtech, one for Cisco, and of course we can adjust this according to your needs. And these metrics or these attributes will be sent to the BNG once we have authenticated the device. So let's have a look. This may take a little bit of time now until the Fritzbox is coming up again and asking for access with the access request. Let's go through and see if we already see something coming up. Not yet. So I'll pause here and I'll come back to you once I see the request coming from the Fritzbox, and you will see the access answer from our radio server. Alright, some minutes later now we can see there is another access request coming from the device, the Fritzbox 5491, with the challenge in the password. We see where that is coming from our router, which is known to us, and based on this we can see the accept. So we see the frame protocol. These are just our default values. We looked at group 0 in our database. So we have PPP as the frame protocol. We have a limit of 1. We have a framed MTU 1492. And we can see the interim interval is 300 seconds, so 5 minutes. And the session should only last for maximum 1 day. And then below these vendor specific attributes here, these are the downstream and upstream bandwidth, 10 megabit, 1 megabit, signaled in different ways. So here, for example, we have the Ascent Communication Inc., where you can see the metric. We have it in a different shape in the Whisper bandwidth max down, for example, here. So these are just, for different devices, and also we can do this via Cisco. Cisco has yet another IPQoS policy classes, which we define here. And as I said, these metrics can be specified in our configuration, depending on what kind of BNG you have. But it doesn't matter if you send multiple of them. Usually the device will pick the one which it is common to, or it's familiar with. And just a second later, or even less than a second later, we get an accounting request, basically now telling, the BNG is now telling, okay, the device is online, so we have a session start. We also get told the IP address, so in this case it's 32.1. And yeah, and this way we know that the device is online now, and we also get to know the IP address. And we, of course, we respond with an accounting response, so that the BNG knows that we understood the accounting request coming in. And one more thing I forgot to mention is that in the accept, you can also see the framed IP address. So this is the IP address our Radius server handed out to the device now, based on our RAD IP pool table. So if you go back here and look for our table, let's go back into Postgres and look for the RAD IP pool table. You will now see there's this one IP address has now been reserved for Fritzbox 5491. We can see the MAC address basically, or the calling station ID for that matter. And we can see the expiry time, which is basically 1 day. And you can also see the NAS IP address. So after we saw that the session was properly accepted, and we can see that the IP address has been assigned, in this case the 32.1, we should also see on the router on the BNG that the session is up and running. And we can do this by show PPPoE server, and you can clearly see that the user FB5491 is up since 36 minutes now, with the remote IP 32.1, which corresponds to the IP address we handed out via Radius. And you can also see how many bytes have been transmitted and received. We get this information regularly, every 5 minutes, via our accounting. So if you look here and we look for accounting requests basically, or accounting responses, you can filter for this. And we say or 5, I think it is. And there you can see, if I refresh, you can see that clearly every 5 minutes we get our accounting request from the BNG, and it will always tell us how many bytes have been transmitted. So octets, input octets, output octets. This way we can later on draw diagrams and see how much the customer used from his bandwidth. Besides this, we can now, if we go to NMS Prime, to our contract, you see this is the modem I created, the 5491, and you can see it got green now because we got the accounting telling us that the device is online. And if you go to the page and go to the modem analysis, this is what you will end up with. So you can see the modem is online, we can ping it properly. We can see, from the real-time values we don't see that much yet, because we didn't set up TR-069 for now. But at least what we can see, but we will do this of course later on, or in the next couple of sessions. And what you can already see is data coming from Radius. So we can see this current session, when it started, when it was last updated, what the BNG IP address is. And also down below, of course, you don't see a lease because we don't use DHCP here, but you can see the config file. So this is our our Genie SES provision, basically, and which has not been run yet because the device has not been reset so far. This is just the provisioning from the last bootstrap. And you can also see the last sessions, which is basically only this one right now, So it lasts already since 25 minutes. And you can see the in and out bytes and also the IP address and the MAC address. You can also see the read replies. So this is basically what we had before in our database. You can see the default every device will get, and then the QoS specific attributes which we sent. And of course these are coming from the contract, because the contract, if you remember, or actually not the contract but the modem, or actually the contract, here you can see the item, which is 10 to 1, so 10 MB download, 1 MB upload, and based on this we assemble the metrics which you can see down below here. Furthermore, we might, I'm not sure if this is already in, but we might see, we can already see the traffic. This is coming from, as I said, from the BNG. The other stuff has not been set up yet. This will be done, the other metrics will be retrieved via TR-069, but for this we first need to connect the device with our Genie ACS server and actually also set up Genie ACS altogether. We can do this theoretically directly. So here if we go to Genie ACS, you will be greeted with the initialization wizard here. I let it do everything besides the presets and the provisions, because I'm not really interested in them, and we will provide our own when you create modems. So I'll just say abracadabra, and now it will initialize everything and it will tell me, okay, the username and the password is admin. So of course I need to change this as well. So let's go here and say admin, go to login. I see no devices yet, which makes sense because I still need to configure the Fritzbox in such a way that it will talk with the new IP address of my new instance here. But what I can already do is go to admin and go to users, and here I can just change the admin password. Let's see. Like this, and now we're good to go. And what you may have already seen is that we have some presets here. So we have one is for the provisioning. You can see this is reacting on Bootstrap, and this corresponds to the config file. So if we go here to our config file, you can see this is the syntax of Genie ACS. This is basically what's happening when the device is coming from after a factory reset. It's coming up with Bootstrap event, and then we'll do what we set already in the config file. If you go back here into the config file for the 5491, we said we want to set the periodic interval and enable it, the inform. We want to provision the PPPoE interface and some voice over IP. And this is what you can basically see here as well. So we say periodic inform enable is true, the interval is 300. We have our PPP connections, PPPoE details for connecting, and we don't have voice enabled. Well, I mean, we didn't set up any voice yet, as you can see here, no zip devices, so this is not filled. And based on this, you can see the corresponding provision here in Genie ACS. So you can see that it will only react on Bootstrap, 0 Bootstrap, and it will only react if the serial number is the right one. So, and the serial number obviously you saw here. So this is the information where this is coming from. And then we push all this information based on the config file into Genie ACS. So we have a preset, which if both matches, so it's a Bootstrap condition and the precondition serial number is met, then we will call, or Genie ACS internally will run the provision prof-7, which we can click on here, or we can look here. And here you can see basically our inform enable, our interval, the connection information, and so on and so forth. So it's very tightly integrated. You only need to configure this, or basically just create a modem from here, and we will do everything in the background such that the presets and the provisions are automatically pushed and updated. There's one more, which is the monitoring provision. This is reacting on periodic events. So we, as you remember, we set in the provision the device should talk with us every 300 seconds, and when it does so, it will come with a periodic event, and based on this we will create a provision called monitoring, and this the ID here, the 6, is referring to the config file ID 6. So since we did not configure this, we will do this later on down below. You will later on see that we actually create a monitoring provision as well, which is querying certain parameters every 5 minutes, and this way we'll be able to draw the diagrams and so and see how certain properties change over time. So the next step for me would be now connecting the Fritzbox with our Genie SES server, and once this is done, I'll get back to you and we'll have a look how the provisioning and the monitoring will look like. As I mentioned, now our task will be to interconnect the Fritzbox with our Genie SES server. If you remember, in the beginning I said on the Fritzbox we have a profile set up which basically survives factory resets, which tells the device that there are default PPPoE credentials built in, and it also tells it where it can locate the ACS. So basically the ACS URL is configured on the device. If you look closer into this config, we have two files which are important. First off, we have the AR7 config, and of course this is vendor specific, but this is just the way it is here on the AVM Fritzboxes. And here you can see that we have default PPPoE credentials. So we have a device or credentials with the username NMS Prime and with this password. And of course we need to set this up in NMS Prime such that the device will come up initially, will get some way of connecting to our ACS server, and from there on we will provision it with the correct PPPoE credentials, which is device specific. So the first thing we'll have to do is going to NMS Prime and creating such a modem. The first thing what we need to do before, or what would make sense, is just to create a dummy config file which does not contain anything, but which is just used, just to have a config file which is basically not doing nothing, or a provision for that matter. So we'll create one, call it initial maybe, PPPoE connection or something like this, and it's of TR-069 type, and that's basically it. I mean, we can of course could give it also a dashboard, for example empty, because we don't really care about it. And now we have our config file, and now we go to our contracts again, go to this. You could of course create an initial contract as well. For now I'm just setting this one up in here as well and saying okay, we call it initial maybe, initial PPPoE connection. Config file will be the same. Now the MAC address, we can specify basically anything, we don't really care. So let's just do something like this. And for the serial number, since we don't really want to provision anything via Genie ACS, we can just do the same. Doesn't really matter. But of course the username and the password will matter. So now we choose username NMS Prime, and as a password the one which is burned basically into the device. And we want of course to have internet access because we want it to be able to communicate with our Genie ACS server. The QoS doesn't really matter. It could be a one which doesn't have so much up and down link speed, because it's just about really the initial provisioning. And now we can save it. And so this will be the modem always used if a new device is coming up with this default profile. We'll be able to connect. We know its username and its password. It will get an IP address, and then it will talk with Genie ACS. We will identify it based on its serial number, just like we did for the Fritzbox 5491. Based on this, we will identify it, and then we will push all the metrics according to the provision of Genie ACS to the device. Then it will reboot, and when it will not come up with the default credentials anymore, but with the device specific ones. That's kind of the flow. And now if we look into the other file, so this was the PPPoE credentials. If we look into the other file of this default profile, we also have a management URL here. Since this is testing, we don't have any encryption, so we use HTTP. And since this is testing as well in our demo lab, we also just use an IP address. Later on, of course, if you go into production, you should always choose HTTPS for encrypted traffic and to encrypt the traffic, and also you should use a host name, because it may happen, of course, that at a later point in time you may want to reorganize your IP pools or your IP assignments also to the VM, and then you would have to touch each and every device again, and so it makes much more sense to use a reasonable host name here, and then you just have to touch the DNS server, change the corresponding IP address, the A record, and then you're good to go. But for now, we use unencrypted and just an IP. And of course, this is the default ACS port. So what we have to do, so far you saw the Fritzbox was not able to communicate with our ACS server. And the reason is that this IP was actually used by a different VM, which we were using as well. So it was actually communicating to a different VM. Since we can't change this here, this needs to be done by AVM. We have to change the IP address of our VM to this one. So to do this, you will see that currently I have the 172.20.0.3, and of course I want to change this to 0.1. So with Rocky 9 or with Red Hat Enterprise Linux 9, the way to configure network interfaces is a little bit different now, because you can find this in the network manager. So I should have a connection called ENS10, or actually VLAN. We're talking about VLAN here. So this one. And basically what I'm going to do is just change this to 1. And of course I made sure that the 1 is not used by the old VM anymore. And now I will restart the network manager. And you should see that I'm now having both. Let me just delete the 1. So let's restart again. Now we should see that we only have this 1. And now the Fritzbox should be able to communicate with us, and we can check in the file var log genie-acs CWMP. And here now, once the device will talk with us again, which should happen every 5 minutes, we will see some output, and then we should also see the device on the genie-acs URL, on the web GUI, and I will show you once this happens. I will come back to you. Of course, what you also need to make sure is that the CPE is actually allowed from our firewall point of view to communicate with us. If you remember, we hand out the IP address 164.32, or if we go to our IP pools, which is basically the same. You see for the router, for the BNG, we hand out 32.0/24, and if we check our firewall for the CPE zone, it's clearly in here. The port 7547 is allowed, so this should definitely work. We just have to wait a little bit until the device will communicate with us, and then I'll come back to you. Alright, after a little bit of trial and error, I figured out that the config I presented you was actually not correct. It's not the 172.20.01, but it's actually 16.01. This is the most current profile which is pushed onto the device. So I had to change the IP address once more again to 16, and now you can see I see the periodic informs coming. A new device was registered because, of course, this is a new instance of genie-acs, which didn't know this device before, so it learned it now, and you can see periodically you will soon see every 5 minutes there will be periodic informs coming. And also what you can see is now, if I refresh here the page, there's actually 2 devices, but the one we're really interested in is the Fritzbox, and you can see we can ping it, so this works well. The next step would be to factory reset the device and see if the provisioning works or not. So of course, if you want to see if the connection between GNASUS and the CPE works properly, there's the button Summon, which will initiate a connection request towards the device, and then the device will come up with an inform, and based on this some metrics will be queried by GNASUS. So you can just try. I mean, right now we see the log is empty. If I go to Summon, now we have a pending task, and you see connection request was coming in. Based on this, like the inform was coming in, and then based on this, GNASUS was querying certain parameters, both the names and the values. And now we have, for example, here we know what kind of hosts are connected to the device and so on. Of course, you can also query other information, whatever you wish. Just click here on, let's say, for example, maybe the software version. You can click on it, hit commit. Now it will query this, has been committed, and now this is refreshed. What you really are interested now is to factory reset the device and see if our provision cycle will work properly. What we will expect, so let's just first click reset and commit it. Task has been committed. You see there was a connection request coming up, and then we set a factory reset. What will happen now is that the Fritzbox will load its initial config. So it will come up with the initial PPPoE credentials. It will be identified from NMS Prime using the dummy modem we created, basically the initial PPPoE connection modem. Here we recognize the device and will allow it to have internet access with 10 megbits download, 1 megbit upstream. And then, well, the device will tell its serial number like it did before, but now it won't come up with a connection request, or it won't come up with a periodic, but what it will come up with now is with a bootstrap. And since it's a bootstrap, in our preset we will match this device, the event is bootstrap, so we will launch basically this provision, and the provision will then push the new PPPoE credentials in, and will also set up the inform interval and the enable. And this way now it will switch over from this credentials to the device specific, which is this credential basically. And then we will have the modem set up in the correct way. And of course, if you were to set up some SIP devices and whatnot, we would push even more info into it. But what we want to try right now is just if this whole cycle works. So basically reset, coming up with initial credentials, being identified by GNASUS, push the new information into the device, and then the device will restart with the new credentials, and then from there on it will have the proper QoS, which is for this device. In this case, of course, it's the same, but of course, your customer may have a different QoS which he subscribed to or she subscribed to, and then based on this, everything works as expected. So we should see sooner or later. Usually this takes around about 5 minutes for the device to completely reset, and then once this happens, I'll get back to you. So as you can see right now, device is coming up with a bootstrap. GNASUS is now trying to get parameter names. It got the parameter values, and now it also set the parameter values. So now it basically checked what kind of credentials, PPPoE credentials do we have, what kind of interval do we have the interval enabled for the informs, and based on this it now basically got the difference between what's currently set in the device and what we want, and based on this it now sets the parameter values. So now we have pushed in device specific parameters into the device, and now the device will reconnect, and soon it should come up with a new IP address and with a value change, and then we will know what IP address it received. So as you can see now, 2 minutes later the device rebooted. It got now the 164.32.1. We see it booted, so it basically rebooted, but it didn't came out of a factory reset like before, so the provision didn't trigger, and it told us via value change that it has now a new IP address. And we should see this now in in here, if we go to our contract, we see the initial PPPoE connection is currently green, briefly, because it was logging in via this credentials, but now it also connected via the device-specific credentials, and we see it's green, so it can be pinged. Just to explain what I explained to you before, you saw during the bootstrap that it was getting a lot of parameter names. So first off, it's just identifying what kind of parameters are available and do they match with what we have in the provision. So if you look here, we're talking about management server, about WAN device, service, voice service, and whatnot. And it first tries to figure out, do these parameter actually exist on the device? And only if so, it will figure out how are they currently set and how should they be set. And we can really nicely check this, of course in this case because it's not encrypted. We can easily dump this traffic via TCP dump and look at it via Wireshark, and we can have a look here. Here I just have the communication, and you see this was 11:08:18. So if we look here, it basically started here, and as you can see, I can make it a little bit bigger for you. It starts with the inform. It's all XML based because TR-069 is XML based, and then we have an inform response from our server, Genie ACS server. Then Genie ACS is asking for certain parameter names. For example, does Internet Gateway device exist, or what is below this? And now the Fritzbox is telling us we have device info, we have management server, and whatnot. And this is happening a lot. You see again, get parameter names, response, names, response, and so on and so forth. So now it tries to figure out the tree of parameters, and eventually you will see, also you saw here, it will do a get parameter values, and we'll see this soon. If I go through names, here we have values now, and now it's querying for, and you can see this nicely here, the inform enable, inform interval, enable interval. It's asking for the password and the username of the PPP connection, username, password. It's asking for voice profile and the current language. So we have the voice profile enabled, line 1 enabled, and the current language. So now this is the request towards the CPE. Please tell me what kind of how are these properties set, and the answer will be enable is set to 0, so it's not enabled, but we want it to be enabled. The interval is also set to 0. We want it to be 300. Then the password is usually not transmitted from the device because this is a security, could be a security issue. So passwords are usually not transmitted. Then we have the username, which is NMS prime. If you remember, we had here NMS prime is our default credentials, so that makes sense. And then we have the enable, which is disabled. The other enable is also disabled. This is also not what we want. We want both to be enabled. And last but not least, we have the current language. And the current language here is German, DE. We want this to English. Okay, so basically all the settings we see are not correct right now. All the how many? 1, 2, 3, 4, 5, 6, 7. All of them are incorrect. So last thing Genie ACS will do is it will try to correct these values, and it will do it by a set parameter values. Here we have the inform interval, enable is now true. Interval will be 300 according to our provision. The username and the password, you will see, password will be set. Username is set to the device specific one. Both voice profile and line 1 will be enabled, as you can see, and the current language will be set to English. The device finally responds with a set parameter value response saying everything's fine, and then if we just I can refresh, eventually it will come with the value change, and now you can see every 5 minutes. So at 11:10 it was coming up with the value change, and now 5 minutes later it's coming up with the periodic. So just as we expect. Of course, currently we do not respond to periodic inform intervals. This is because we didn't set up our config file accordingly. This is what we're going to do next up, and then we will have a new provision which will react on the periodic in this case this one here. It will be called monitoring 6, and you will see this coming up here. But this is for the next step. As I mentioned, what we're trying to do now is to set up the monitoring provision properly. To do this, we will be using our config file. In the config files, we have our Fritzbox 5491, and what was not available before, but what is available now is down below here, build your interface. With this, you can basically add new list. So let's say my new list. You can add it, and then based on this, you can just push information from the available parameters over to NMS Prime, basically. And of course, you can rename this as you wish. But what you may see is that we don't have all the parameters we may want. So for example, you can see some of the parameters are already available, and these are the ones which have been identified by GNI-SUS in the very first step when we did the provisioning. But of course there are some, or a lot of them, are still missing. So in order to retrieve them, we'll have to go to GNI-SUS, we'll go to our device, our Fritzbox, and there you can basically do Internet Gateway device, and you can refresh more or less everything here. You can click on this, and you will see, I mean, currently we have periodic inform, which is fine, but now we can commit this change, and this may take some time now. Because now it goes from the very top to all the subtrees, and we'll try to identify all available parameters. So we can click on commit, and now it's pending, and you can see it's doing a connection request. It's getting some parameter names now, and some values and so on, and this will take some time, as I said. So I'll stop here. I'll come back to you once it's done. So all the parameters have been identified now, so we can go and start basically configuring our monitoring string. So I'll just hit F5 to get the latest tree, and here you can see it's just a subset, and I can search for it, and this way I can build my own interface. So I have already an existing interface from our old demo system, which you can see here, and this is basically how I want it back again. So of course I could just go to my database and copy paste it, but I want to show you how to do this in real time, so that's why I'm going to do it here live. So the first thing I want is like a new section called general device info. So I go here and say I add a new list. Then I want the manufacturer to be shown. So let's search for manufacturer. You see there's one. I just put it over here, and then I will want to call it vendor. This is just a name I can give it whatever I want. So now I'm done with the first section. Now next up I want the model name. Model name. So here we go. I need to refresh, as you saw. So I'm going to put the model name here, and I call it device. Why not? Next up, I have the software version. Software version. Put it below and call it firmware. Next up, we have the spec version. Of course I can put it like this. What I can also do is just say I want to move it to the general device info, and we'll put it below. So especially if you have a lot of entries, it may get tedious to always move this over. So we have this possibility here as well. Spec version will be called hardware revision. Then we have a serial number. So serial number, I'm going to push to general device info. Then we have, and of course I need to call it serial number, like this. Then I will do the last inform. So I just want to see when it last came up and was last online. So move it here, and I will call it last inform. Then we are going to look at the uptime, which is this one. Let me just first add all these parameters and then I will rename it. Then we have reboot. Reboot. Which I think is a special case which we have to cover later on, because this is a metric built into Genie ACS. So let's skip it for now. We have the IPv6 status. So I'm not sure how easily this will be. Dot status IPv6.1.status it is. Here we are. Then we have the connection status of the PPP connection. Connection status of the first device, first one device, first one connection device, first one PPP connection. So this one, I'm gonna add this. Then we have the connection request URL. Connection request URL. We have the username of the first user. This one. We also want to see the password. And we want proxy custom forward. Proxy custom. From 111 again. So it should be DNS v1 proxy custom forward. Yeah, it's not about to enable, it's about to forward itself. So this is the one. Okay. So now we can rename. So we have the uptime again. Uptime was, it's just called uptime. We have IPv6 status. We have a PPPoE status. We want the login URL. We'll see this later on. The VAN login name, username, and the password, which is here. And custom DNS. We call this custom DNS. Now we just need to, of course, we can continue. And now we want a new table or a new section called data table wide area network connection infos. So we can do this. I'll just say I want this as a new list. Like this. And here I can add some more. So I want the physical link status. Link status. I'm going to add this, and now of course I'm not going to add it to the general device info, but to the data table connection infos. We have our downstream max bit rate. Downstream max bit rate, I think was, yes. And also the upstream, as you can see, upstream. Then we want the max speed. Max speed. Again, first for downstream and then for upstream. Down, up. Okay, so now we can rename this again. Let's go down here and say the physical link status should be called link status. The downstream max bit rate shall be called downstream max bit rate in megbits per second. And here you can see now an interesting bit. We get the downstream max bit rate in kilobit per second. Kilobit per second, yes. And we want them in megabit per second, so we need to divide this. And we have this functionality here that you can say, okay, I want to divide by a certain factor. And this way I can adjust the values according to my needs. So next up we have the upstream max bit rate. Again, I'll divide by 1000 here. Then we have the downstream speed in megbits per second. Again, here I need to divide by 1000 because this is in kilobits per second. And last but not least, we have the upstream speed. Also divide by 1000. Okay, so this is the next section. Now we want to talk about the signal quality. And so I will create a new list again. And here I will now look for some more parameters. So I'm going to look for optical signal level. So let me go up here. Optical signal level. This one. Now I'm in my third category. Then I'm talking about the lower optical threshold. Lower optical threshold. There you go. We have the upper optical threshold. We have the transmit optical level. Optical level, here we go. The lower transmit power threshold. And again the upper one as well. Like this. Okay, and now again we want to rename this slightly. So let's go back down to our third category here, optical signal level. We call this optical RX level in dBm. And again, we need to divide this by 1000 because the device will give it us in, times 1000. And now another important bit, we want this information now also to be stored in our database and as a time series database. So we want this as a time series and to see how this changes over time. And if you want to do this, we can say here write value to the diagram, and then I need to select the column where this should be stored into, and I want this in average downstream power. So AVG DS power. This is where I want this value to be stored in my database. And I also want to divide this by 1000 for the database. Like this. Okay, now going further to the optical threshold, the RX, which is here. Just a sec. Here I actually don't, wait a minute. Here we are, okay, right. So I did the RX level dBm. Next up, it's the optical threshold. So let me scroll down a little bit. Right, and now I call this lower optical RX threshold. And I divide this by 1000 again. But I don't want this in the database, so I don't tick it. Next up we have the optical threshold, upper optical RX threshold. Again, I have to divide by 1000. Then I'm interested in the transmit optical level. This is something I want in my database as well. So first off, I call it optical TX level dBm. I divide it by 1000. And I wanted to store it in my diagram. And so I need to say what kind of column are we talking about. In this case, I wanted this in average upstream power. And of course, this metrics you can later on in Grafana access. If you want to build your own dashboard, you can easily use these columns then. Then we have divide by 1000 again. Then we have another threshold, which I don't want in my database, but I call it upper optical TX threshold. No, wait a minute, first it's the lower optical TX threshold. And I will divide by 1000. And last but not least, I will use the upper one as well. and divide by 1000 again. And the very last one is I want another table, which should be a scrollable data table. That's why it's called PT. It's paginated, as you can see here. So I will just say I want a new list, PT system log. You see, based on this prefix, we know is it paginated, is it not paginated. So this should be a paginated system log. And in there, I want to have the device log. So I'll go up there again, look for the device log, add it to my system log, and I will call it log entry. And that's it. And now I can hit save, and then this will be saved into our database. And from there on, we'll soon see that a provision will be created to query this task every 5 minutes. Alright, and once you're done with configuring all of this, as I said, you just have to hit the save button here, and then this is pushed into our database and also into GenieSUS. Of course, you can change it any point in time if you're not happy with what the translation will be. Maybe you just want to call it firmware, then you change it here and save it, and then this is saved. And also again pushed to GenieSUS. So what we did now basically is we did provision the monitoring provisions basically, or configured the monitoring provisions. So if we go back to our modem, we have one modem of this type, which is, if you look here, it's modem number 7. Modem number 7 has the config file of ID 6. So if we now look into GenieSUS, back into our presets, we have, of course, the normal bootstrap provisions, or presets in this case, and we also have periodic ones now. And we were talking about modem 7, so this is the monitoring of modem 7, which will react on event number 2, and event number 2 is periodic. So whenever the modem is coming up with the serial number, this one, and a periodic event, then we will hit the monitoring provision 6, and this 6 here is referring to the config file 6. And if you click on this one now, you will see that we are now getting all these metrics which we just configured, right? So we are doing the manufacturing. So if you go back to the config file, you see we have manufacturer, model name, software version, spec version, and so on and so forth. And you see all of this here. And these are the values which we didn't want to have in our diagrams. But on the other hand, the first one we wanted in our diagram is the optical signal level. And you can see here in the optical signal level, we now have here also the divisor, and we push this into our average data downstream power and into our average upstream power. So now every 5 minutes when a device is coming, we will run this provision, and based on this we will populate our database, and Grafana will then be able to show the metrics from the database. That's the whole magic. And whenever you create a new modem, so let's say I create a modem number 9, which has the same config file 6, then there will be a new monitoring preset called mon92, again referring to mon6. And of course there will be a new bootstrap provisioning for the initial provisioning of the device. And a couple of minutes later, we now see the device was doing periodic informs every 5 minutes, and we didn't have a periodic provision script yet, but since we configured this now in our config file, the monitoring provision was properly set up, and now GenieSUS is querying for these names and these values, and you will see that now we have the two values we're interested in. So we're interested in the optical signal level and the transmit optical level. We divide both by 1000, and then we push this into the average downstream power and the average upstream power. And this is what you see basically. These are the two values here which we look at. And from now on, these values will be every 5 minutes will be pushed into our database, and from there we will be able to display them in Grafana in our analysis dashboard. I will give it a little bit more time to populate some values in the diagrams, such that we'll have something to look at. Some minutes have passed, and now if we go to our modem analysis page, you will see that we will get some values now. So the modem is online, obviously. You can see the real-time values just according to what we configured before. So if we go back to our config file, you see we first created general device info, when vendor, device, firmware, hardware ref, and so on, all of this. Then we created a new section called WAN connection infos. You can see that here. Then we have signal quality over here. And now, of course, we want, before we had this as rows, now we define this as columns. That's why it's not showing in this direction, but in this direction. So you're very flexible in how to display the various values. We have our signal quality, and last but not least, we have a paginated system log. So you could theoretically skip through here, but because the sys log is not that populated yet, you can't. And of course, you can also see, if we zoom in a little bit, maybe 30 minutes or 15 minutes, you see 2 points have already been taken or retrieved from the device, and you can also see the traffic. So basically now everything is set up according to our needs, and the provisioning and the monitoring works really well. The last thing we can check out is some additional commands. You can see here on the very top we have some commands which are here in German, but of course they could be translated to English just as you like. And with these commands we can basically do some interactions with the device. So for example, we could enable the remote access, and for this we need to set or get certain parameters via Genie ACS, or you could deactivate the remote access, where you would, for example, set enable to false and remote access cable to false, and then the device, you can't access the device via the WAN gateway anymore, or the WAN interface. So we can try this now to activate and deactivate the remote access. We also have more commands, as you can see here. For example, you can do a factory reset from here directly. You can also poke the device to communicate with you. You can also do some Wi-Fi and DNS settings, but maybe we'll first try to do the to enable the remote access. Okay, so to activate the remote access, we really just need to choose this, click on submit, and then you will see in the background there will be some names get and set, and this is according to what we did in our config file. So here we need to set 2 parameters and get another one, and this is basically exactly what happened here. And now you will see that there is a WAN login username set. So theoretically everything works well. We should now be able to go to HTTPS, this one. We see it's available. Of course with a certificate error, but this is okay because it's a self-signed certificate. Sometimes these devices are a little bit slow on the remote access, and you sometimes have to refresh them. But here you now greet with the username and the password. The username is always changing, it's randomly picked, and that's why we display it here. So use this, and password is NMS support, like we did in our initial. If you look here in our initial provisioning, we set, I believe, no we didn't, but this is here, we set it here to NMS support. That's why it's being displayed here as well. And now we should be able to log in. Let's see. Yep, seems to work. As I said, it's a little bit slowish at times, and you may have to refresh the page at times. Okay, let's try to log in again. Password is NMS support. Log in. want to change this, so keep it in English. But you basically can see, okay, I'm now logged in, and let's just do English if possible. Maybe we could do UK. But anyway, I mean, this is just an indication that this works. We can now log out again. And now I can disable this again if I want to. So I go to deactivate remote access. Another task which is being done now. And you will soon see that action is being executed. And so now you will see, since I deactivated the remote access, I cannot access this anymore. It's just spinning and spinning. I can't log in. So even if I, let's say, for example, with wget try to get this page, it's just said no router host because its firewall is not allowing me to connect to it anymore. So I successfully disabled the remote access and am now back into where I started with. So as you can see, it's very simple to add new commands. You just have to define them here with the command word, basically, and then you just have to set how the command should be called, and then you can set or get as many parameters as you wish. They just need to be line by line and have all the same name, and this way we can kind of do a multi-stage process if needed. This pretty much concludes the TR-069 FTTH provisioning and monitoring. So let's see you in the next session.